Over the past few years, coherence change detection has become recognized as a very powerful and useful change detection technique. For this reason, a lot of effort has been put into developing operational tools to make exploiting this technology fast, accurate, and easy. One such tool is EZ Sentinel CCD. Interferometric processing of Sentinel-1 imagery is complicated. This sketch shows the radar beam transmissions as the satellite orbits the Earth. Each transmission burst yields a small image-ette. As you see here, a full Sentinel-1 radar image is composed of 3 swaths and up to 30 sub-imagettes, which we term bursts. The processing complications arise because interferometric processing must be done on the separate burst pairs, which the software must identify and link. The burst products are then mosaicked into swath products. The imagined interferometry module is accessed by selecting raster, the radar toolbox, interferometry drop-down list. This module has several tools to automate processing of Sentinel imagery. We have the Sentinel Swath CCD, the Sentinel Swath Processor, and here, EZ Coherence Change Detection. Clicking on this option will bring up the user interface. The software ingests the imagery at the swath level, so you'll have to navigate to a directory where you have your Sentinel-1 data stored and select the appropriate swath for processing. Here we're going to use interferometric wide swath 1, vertical, and select the XML file. Similarly, you'll have to navigate to and select the corresponding pair to prepare the interferometric processing project. The default parameters here are all intelligent defaults. Taking these will normally give you a pretty good answer, but you do have some ability to change things if you have a difficult data set or want to try for a more precise answer. Similarly, the multi-look parameters are set for a maximum resolution and a good answer for most data sets. Again, you can change them. For example, you may want to change to a multi-look factor of 3 to process a quick look to make sure you want to do a full resolution processing of the data set. Generally speaking, these defaults do an excellent job. All of your created products will end up in what we call a work directory. This is automatically populated by your selection from your imagined preferences, but you can, if you desire, select a different working directory. Similarly, you'll have to give a name to the coherence product that you're going to produce. Again, it will automatically default to your preference work directory, and you can put in anything you want to put as your output name. That will then become the root name for all the products that are produced. You can see here the interferogram and the multi-temporal coherence, the coherence texture, interferometric land use. These are all automatically named with the same prefix that you selected here. Then all you have to do is click OK, and the processing will run. When the calculation process has completed, the process list meter will indicate 100% here, and it will say done. At that point in time, we can dismiss this process and close the process list. All the intermediate images have now been generated, the products are created, and we can view these in the directory. First, we can look at the simple coherence image. Let's do a fit to frame, orient to the map system. Here we can see the coherence image of our 9 or 10 bursts mosaic together. You can see we had one problematic burst here in the middle, didn't co-register well. Perhaps we need to go back and tweak those co-registration parameters a little bit to get this one to complete. And we can also look at the more sophisticated product images. For example, the multi-temporal coherence here, and the interferometric land use, the IILU image. This is a favorite image, very interesting image, because it combines 2 different change detections. Change detection in the magnitude and change detection in the phase. So for every pixel, this image has two totally different change information contents, color-coded for interpretation. So there we have it. Sentinel CCD made simple.